So what y'all need to understand, when we talk about flow rates, that means what? That means how fast the infusion is going into the client, correct? Well, we have two types of flow rates. So do y'all see this one? This is called by gravity. So literally, we are not using any pump when we're doing a flow by gravity. Literally, the nurse, do you see by this little dial, they turn it, and if it works, that's not going. So we count per minute the amount of drops that goes into this chamber, okay? That's called by gravity. We don't use the pump at all. What do you think is safer?
Pump.
The pump. The pump is safer. So a lot of times you'll see by gravity in the OR, a lot of times in PACU, they're hanging things by gravity, antibiotics, things like that. But for safety reasons, for instance, your critical care drips will always be on a pump. Because isn't a pump much more accurate than us kind of dialing this thing up and down and counting how many drops per minute are in the chamber, right? Pumps are more efficient. So, either way, you need to know how to calculate the flow rates for both. So when we're talking about by gravity, what do you think is your X?
Drops.
Are we counting the drops per what?
Minute.
So by gravity, your X is always your drop per minute, okay? Well, let's talk about the pump. You know we set our pumps, right? So what matters is the volume that we're infusing and the rate in which we're infusing it. So can y'all see this?
Yes.
When you set it by a pump, it is always, what is your X?
Million.
It says ml per hour. Okay, so on a pump, your X will always be ml per hour. So by gravity, drops per minute on an IV pump, your X is always mLs per hour. Okay, that's what we're always looking for. When you set your dimensional analysis up, GTT better always be on top, minutes better always be bottom. For your pump, mLs better be on top, hours better be on bottom, okay? Something we have to talk about by gravity. So we don't have a pump, but what you need to understand is we have a lot of different tubing. So we have micro drips versus macro drips. So macro drips, does macro mean larger?
Yes.
That means the diameter of the tubing is bigger, so will the drop be bigger?
Yes.
So more will be infused into the client. Micro drips, the diameter of the tubing is smaller, so will less go in. So your macro drips, it's always per 1 ml. We want to know how many drops will go in per 1 ml. So with your macro drips, you can have 10 GTT per 1 ml, okay? You can have 15 GTT per 1 ml, or you can have 20 GTT per 1 ml. Those can all be macro drips, all of them. So look, do you see how they're all different? Will your book have to specify what type of tubing you have for macro drips? It can't just say macro drips because you have different numbers. Micro drip only comes in one number. Your micro drip is always 60 GTTs per 1 ml. Okay? When you see math problems, does it have to specify 60 GTT per 1 ml? It could just say micro drip. Do we have to have it ingrained in our brain that we know if it says micro drip, that means the tubing per 1 ml of fluid will have 60 drops getting to that client? Okay? Something else you need to understand about drops. When I am increasing this little rate and counting, I have my minute hand and I'm counting the amount of drops per minute. Can you half a drop? No, we can never slice a drop in half. So just like our full doses, will you ever have a decimal for a drop factor?
No.
Or for your GTT per minute? No. So you always, for your X, for GTT per minute, you will always round to the whole number. Always. on your test or on any exam, quiz, anything here on out, if your answer ends up being 167 GTT, 167.45 GTT per minute, we have to always round to the whole number. How many drops per minute is it? 167. You still use your rounding rules. Less than 5, you go to that, you stay with that number. 5 or greater, you go to the next number. Okay? So, tell me how many drops per minute I have.
173.
173 drops per minute. That is your answer. If you leave it like this, do you get it wrong?
Yes.
Every time. Because we can, y'all understand, we cannot slice that in half. What y'all need to understand about mLs per hour, mLs per hour is based upon a pump, okay? So, I know it's hard to see with this pump, but we can have up to the hundredths place. For instance, a critical care drip, our infusion rate can actually be, because the pump can go to the hundredths place. Remember, we're not going to say hundredths anymore. I should have said second decimal, right? The infusion rate can go 125.24. It can go to the hundredths place. So for mLs per hour, you always follow rounding rules. But just critically thinking, would you ever have a no? Could you even program that on the pump? It only goes to the second decimal place. So when it comes, when we are talking about mLs per hour, whose rules will you always follow? Whoever specifies your rounding rules, first decimal or second decimal. But can we ever have past the second decimal? No, there's no way you can program a pump for more than that. Do we get that? Okay. Any questions about this? So let's start working on our problems. So I want y'all to go to the bottom of page 425. Can you see example 1? So we always look for our x first. When we read example 1, what does it say our x is?
Drops per minute.
It says how many drops per minute should be given to infuse the total amount of hexavan. So our x is drops per minute. We always start with our numerator. What information in your problem do you have about drops?
15 drops.
You have 15 GTT per 1 ml. So we just learned about that. What does that mean? What is that? What information is that? Yeah, that's our tubing, right? So is that a micro drip or macro drip? Macro drip. So what it's telling us is we are using a macro drip tubing for this client. We know we have 15 GTT per 1 ml. Well, we need GTT per minute, not GTT per ml. How do we get rid of that ml?
We add 500.
500 mLs to what though?
3 hours.
Doesn't it say 500 mLs to be infused over 3 hours?
Yeah.
We have to keep those together. So 500 mLs to 3 hours. mLs crosses out. Are we looking for GTT per hour?
No.
No, we're looking for what?
Minutes.
What relationship do we know with hour to minutes?
1 hour.
1 hour to 60 minutes. Hours crosses out. Do we have our X?
Yes.
Where we need it? Drops is on top, minutes is on bottom. So when we do the math, somebody do it for me. 15 times 500?
7,500.
500. Over 3.
Over 180.
100.
Is what? 41.6.
6.
Well, let's just make sure we do. So we end up saying 41 GTT per minute. Will you get that answer wrong?
Yes.
42.
How do we round it to the right, to the whole number?
Use
0.6
rounding
goes to?
42.
Yes. If we put this, will we get it wrong?
Yes.
Yes. If it had said 41.2, how many drops per minute?
41.
41, okay? You still use your normal rounding rules. How do we feel about that? Let's keep practicing. Flip over to example 2 on page 426. So, we always look at the end of the problem. What is our X?
How many drops?
Drops per minute. Well, when we look into our problem, what information do we know about drops?
It is.
60.
We have 60 GTT per what?
1 ml.
What do we know this is?
Micro.
Could have had said micro drip. And we do not have to specify 60 GTT per 1 ml because there's only one micro drip. Do we understand that? So in the problem, if it had said the tubing, the nurse is infusing with a micro drip tubing, do we understand we would have plugged this in? Okay. So how do we get rid of that mLs? What information do we have about mLs? 50 mLs to be infused over
30 minutes.
30 minutes. Do y'all see that 1 gram? Do you think we could use that 1 gram? No. Is that a distractor?
Yes.
If we, for some reason, put the 50 mLs over 1 gram, just remember, how will we get rid of that gram? There's no information in our problem to get rid of the gram. So we do 50 mLs over 30 minutes. mL crosses out. Do we have what we want?
Yes.
Do we have to convert hour to minutes? No, we're already in minutes. So 60 times 50, 300 over 330, sorry. Wouldn't it be,
It's 3,000 is 0, it's 3,000.
so is it 100? 100 what?
Drops.
Per minute. We didn't have to round it. If it had said 101.2, it would have been what?
101.
101 drops per minute. If we leave it like this, do we get it wrong?
Yes.
Okay. So let's do an ml per hour. I want you to go over to page 430 and look at example 1. So what is your X in example 1? Our X is mLs per hour, correct?
Yes.
What information do we have about mLs?
We have 1,000.
1,000 mLs over
12 hours.
12 hours. Do we have everything we need? Isn't that nice? Pretty easy, right? What's 1,000 divided by 12? 83 point, is it 3 repeating?
Yes.
And I would act as your pharmacist or doctor, and I would say round to the first decimal. And it would be what? 83.3 mLs per hour. Okay? In the back of your book, for all your answer problems, they always round to the first decimal. Will you use my rounding rules?
Yes.
Yes. Okay? Let's go on to example 2 on page 430. So look and see what is your X. mLs per hour. When we look at our problem, what information do we have about mLs? 50 mLs what?
Over 30.
To be infused over 30 minutes. Do you understand we have to keep that as one unit? So 50 mLs to 30 minutes. Are we looking for ml per minute? No. How do we get rid of that minute?
60 minutes.
We know there's 60 minutes to 1 hour. Is that correct?
Yes.
Isn't this just the same thing as 1? So we're not changing our problem. Minutes marks out, and we're left with our X. 50 times 60, 3,000 divided by 30. So again, what's your answer?
100 mLs per hour.
How are we feeling about that? Let's do one more. Let's look at example 3 on page 431. So we always go to the end of the problem to see what our x is, and what is our x? Milliliters per hour. So let's look at our problem, and what information do we have about our milliliters? Because we always start with our numerator. 250 mLs to what?
40
40
milliequivalents. Do you see that's one thing? You can't separate them. Because it says dilute the potassium 40 milliequivalents in 250 ml. We always make sure to put the ml on top because we have to start with our numerator. Do we need ml to milliequivalents? Look at our problem and let's see what it says about milliequivalents. We have 10 milliequivalents per what?
Hour.
1 hour. Does milliequivalents cross out? Are we left with our x? That should be a 5. Divided by 40 is what? 62.5 mLs per hour. And I give you no rounding rules. What do you leave it as? 62.5 mLs per hour. Okay? That's pretty simple, right? We will always understand we are either given it via micro drip or by the pump. If a problem ever says, what is your rate that you set your infusion pump for, you know your X will be what? mLs per hour. If it says, what rate by gravity will the infusion go or infuse? Will the fluid infuse?
Drip per minute.
We know GTT per minute. If it says micro drip, we will use what? 60 GTT per what? 1 ml. Don't forget the 1 ml because that's the bottle, okay? And macro drip, will it have to specify? Will we ever have GTT per minute as a decimal?
No.
No. There'll always be a whole drop. And then mLs per hour, you will go by my rounding rules, but we can never set a pump past how much? The second decimal, past the hundredths place. So just to make sure you understand it, on page 437, I want you to do number 2, 3, and 5. Actually do 2, 3, 4, and 5, so you see something to look at.